Hi guys, this video is again in continuation of the most significant gift of God the Almighty to our biological system, but least spoken about. We studied a little bit about transducers in our biological system. Now here I am trying my level best to speak as much as I can for transducers and just try to prove how significant it is in our biological system and how can we not have one full chapter or one full series on transducers in our academic section. All right, so just an awareness about transducers. I again repeat, I am talking in concern with biological system. Transducers in biological system, I'm talking about it. All right. So I feel that less of justification has been done to transducers in our biological system. So here I am trying to just highlight what transducers do in our biological system. Let's understand now a bit of mathematical relationship between wavelength of wave, its mechanical energy, that mechanical energy again then converted into electron volts. All right, so prior to getting into it, we need to understand some basic formula for energy. Now this is energy E, which is equal to h nu. Now h nu is equal to hc over lambda. Now where h is Planck's constant, c is velocity of light, lambda is wavelength, and n, that is 1 over t, where t is time period, is equal to frequency. The situation is y is c over lambda 1 over t. Now formula for c, velocity is n lambda. Alright, so if where n is frequency, as I mentioned already. Alright, so n lambda, so n is equal to c over lambda, which is equal to I over t. That is what is frequency, owing to which c over lambda has been replaced by 1 over t. Alright, and this is represented in hertz. Alright, so now coming back to formula, therefore E is equal to h into frequency. Unit for Planck's constant is joules second, and for frequency it's per second. Alright, so now assume that a wave of 300 hertz strikes our eardrum. Now just prior to that, I also would like to make you aware, or you may be aware already, that frequency wise human audible range is 20 hertz to 20 kilohertz. Alright, now coming back to formula, energy is equal to E is equal to h nu. Now value for Planck's constant is 6.626 into 10 raised to minus 34 joules second into 300 per second. This is hertz, right? So when we multiply these two, the figure that we get is this. Now if we approximate, that comes to 2 into 10 raised to minus 31 joules. So basically 300 hertz has produced 2 into 10 raised to minus 31 joules. So it has done this much of work. Alright, now this work obviously is being done by tectoral membrane. And now this work energy, mechanical work energy, is to be converted into electrovolts. Alright, so it has to be converted into EV by transducer. Alright, now let's understand how is the mechanical work converted to electron volts via formula. Alright, now there is a relationship which says 1.6 into 10 raised to minus 19 joule corresponds to 1 electron volts or EV. Alright, 300 hertz has generated 2 into 10 raised to minus 31 joules. So how much would that correspond to? So I've just shown calculation over here to understand how joule gets converted into EV. Now see, this value which was there, this is in joule, this is in joule, this is in joule, this is in joule, and this is multiplied by 1 EV. Joule gets cancelled, and what we are left with is EV. All right, so what value we get is 1.25 into 10 raised to minus 12 EV. Now we also know 10 raised to minus 12 is known as pico. So it comes to 1.25 pico EV. Now again, formula for work is EQ. Alright, that is volts into coulomb. That's what is work. Alright, so if we actually want to find out how much is the volt generated in our cochlear nerve, then we have to divide work by coulomb. Alright, so work by coulomb, that is J by C. Now when we say EV, 1 EV means 1 electron passing via 1 volt. If we say 1.25 EV, then that means 1 electron passing through 1.25 volts. But what we have generated is 1.25 picovolts. Alright, so what does that mean? Now, if we assume that it is 1 electron which is passing through cochlear nerve, then 1 electron, 1.25 picovolt is being generated in cochlear nerve. Now, this is what is all my assumption. Alright, so presumably 1.25 picovolts are generated in cochlear nerve. The sound wave of 300 Hz would generate an impulse of 1.25 picovolts if 1 electron has to flow through this cochlear nerve. Let's understand job done by transducers in case of light and in case of sound. The basic thing that we have got to keep in mind is energy is directly proportional to amplitude. At the same time, it's also directly proportional to frequency, and when we say frequency, it also means wavelength. Alright, so smaller the wavelength, larger the energy. Alright, so this is what we are going to keep in mind. Now let's talk in terms of light. In terms of light, we found that with stimulus, cis-retinal changed to trans conformation. In doing so, part of its group covers angle theta. So this is what we already had seen in our earlier video, and this is the diagram that we had checked about. Whatever I have done in pencil is the cis form, that is the initial form of retinal, the group which is in cis form, and then as it absorbs light, it changes to transform. This is the final form. Alright, so and doing so, it covered angle theta. Alright, this is there, and the top tau was applied by light source. Alright, that was the energy which we had talked about over here, amplitude and frequency. It all depended upon this talk, depended upon amplitude and frequency or wavelength. This is what we saw in terms of light. Now let's understand what happens in terms of sound. In terms of sound, we saw with stimulation of sound, tectoral membrane moves against hairs of mechanosensory cells covering distance d. This was the initial position of tectoral membrane. Alright, the pencil marked is the initial position of tectoral membrane, and it moved from here to here. This movement was all concerned with sound waves, the disturbance created in endolymph of cochlea. Now, depending upon the extent of disturbance created in endolymph or ripples created in endolymph, and that again depends upon amplitude and frequency or the wavelength of sound waves, this d was covered. So this moved from here, that is distance d. In case, so this was the initial position and this is the final position. So it moved from here to here, so d. Alright, so here we saw theta covering, that is rotational movement. Here it is distance covering, that is linear movement. Alright. Now let us come to the final part. Let us talk in terms of rotational work and linear work. Now we know the formula for rotational work is tau, that is torque, into theta, the angular displacement. So here we have tau, which was provided by amplitude and frequency or wavelength, and theta was the angle covered, all right, by change in conformation from cis to trans. That was the angle theta. So tau into theta gives us work, and we also know work is energy, all right. Now let's talk in terms of linear moment. Now here we had already seen force was again applied by endolymph of cochlea. The ripples in endolymph of cochlea was generated by sound waves. The extent of ripples depended on amplitude, frequency and wavelength. So depending on that, this D coverage is there. All right, so the distance covered is D. If ripple is too much, or rather if wavelength is low, then this energy would be high, force would be high. So as a result of that, it would be displaced too much towards the mechanosensory hair cells. All right, so now F into D is work. We know this is linear work, and work is also energy. So this part is all done. So we have generated work over here. We have generated work over here. Now here, another thing that we have generated was power. We know work over time is power. So in earlier video, I had talked about it. When this work, that is tau theta upon time, if we do that, becomes power. So if it moves faster, and when would this move faster over here? When the amplitude is more, or wavelength is less, or frequency is more. If it moves faster, then time taken for covering this theta is low, as a result of which power generated is high. Now since power generated is high, so obviously the electrical impulse generated also would be high. We hear so many things at a time. Like right now, I'm hearing sparrows chirping. I can hear some music somewhere. My fridge is making some noise there. The people talking around. So many voices are going at a time into my ear. And my transducers are working on it and making me aware about all those noises, all those sounds. How does it happen? That's the mystery which I've tried to decode over here. Similarly, when we see so many things at a time. I see a cupboard here, I see a wall here, I see window, I see sparrows there, I see birds there, I see so many things. I see myself right now, I'm seeing myself on video. So all these things I'm seeing all at a time is happening. So we are seeing everything covered in that angle of 120 degree, which is our vision angle. All right, so many things at a time. So how does our transducer manage it? So these are certain thoughts which I have put in, and let's see how it goes with you all. All right, let's now understand what happens if we are looking at rainbow. Now when we are looking at rainbow, we see Vibgyor or Vibgyor, whichever way you pronounce it. All right, so we see those colors. All right, now those colors, that itself means different wavelength. Then how are we able to differentiate these different wavelength? By same transducers, same light and same retinal. Right, all depends upon. Now when we talk in terms of Vibgyor, we know in case of Vibgyor, the violet which is there, the wavelength is low, whereas in case of red, the wavelength is very high. And why is that? Because lambda is small, and lambda is small means energy is more towards blue region. As we move towards red region, lambda is high, wavelength is high, so bigger wavelength, so lesser energy, so coverage of theta is very small, and in between are these. All right, so when all those colors are striking our retinal for various colors covers various theta. So since various colors are covering various theta, so the work done is different for all different colors, as a result of which transducers responses differently for different colors. Same issue is also with sound. in case of sound, there we saw it was deflection theta. Here we are seeing it is displacement d. All right, so various frequencies, amplitude, wavelength would create various, or rather would cover various distances. All right, so now for example, if I take this, now in this case, obviously it is covering larger distance. Your temporal membrane is covering larger distance. Now since it is covering larger distance, so obviously the sound wave which has, owing to which the ripple has been created, and the ripple that has created disturbance into this temporal membrane has more energy, and obviously it has more energy. Why? Because its amplitude is high and its wavelength is low, frequency is high. All right, so this much coverage. So see, you can see how it is crumpled. The mechanosensory hairs are crumpled over here. So in this case, what we find is, let's go to this case. Now in this case, it is minimal. The energy is minimal. So it has hardly traveled any distance. All right, it has hardly covered any distance, this temporal membrane. So less energy applied over here, less energy applied because low frequency and low amplitude. All right, so because of which hardly there is any disturbance. So the result is the same. All right, so as I have written over here, you can check it out. Small wavelength, bigger amplitude. This is what results. All right, when bigger lambda and small amplitude, this is what results. So this is how sound also, we can differentiate one sound from same sound having varieties, like a flute being played, a person yelling, a girl shouting, all those things at a time our ear can pick up only because for every signal there is difference in response, and that difference in response is owing to this distance is that temporal membrane is creating, owing to difference in frequency, amplitude and wavelength. All right, so guys, this is all that I had for sound and a bit of comparison with light. Now my forthcoming video would be on smell. It would be about our transducers working hard on flavor and fragrances that we experience in our biological system. So let's wait for it. That would be yet another interesting issue. Right? See you then.